All right, here we are in 5.2. We are down to example 7. So we're going to be looking at this graph for all of these questions. The first thing we are asked is to find a path from C to F. So we want to start here and end here. We want to go through B, but we don't want to go through D. So it looks like we're going to start by going down to B. So we go C to B. And if we want to end up at F, probably the easiest way to go is A, H, F. So that's not the only option, but it just asks us for a path. So this would give us the path. Notice it has 5 letters, so it would have length 4. Now we want to find a path from C to F that passes through both B and D. So we could start the same way. We could go down to B, but then come up to D. Remember, we can't do any edge more than once, but then we can come down to A, and then H, and then F. So that would be C, B, D, A, H, F. Here we're asked for length 4. We just found one with length 4, so remember if it has 5 vertices, that means it went down 4 edges. So we could just recopy that one. Okay, so C to B would be 1 edge. B to A would be the 2nd, A to H would be the 3rd, and H to F would be the 4th. Now we're asked to find a path of length 7. So that one's going to be a little harder. We need to put some more edges in there. So let's start with what we did on part B. If I go to B, that would be 1, 2, 3, 4, 5. So I need to find a way to make that a little bit longer. So start at C, go to B, D, A, that's 3 edges. 4, let's go to G, that'll give us 5. Then if we do the loops, that'll be 6, and then 7 to F. So we started at C, we went B, D, oops, that's not a D, B, D, A, H, G. Now we looped, so we put G twice, and then back to F. So 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 8 letters. That means the length is 7. Now the next two are a little more challenging. It says how many paths are there from C to A? So we're only looking at this part of the graph right here. And we want to look at different ways we can get from C to A. So we can go down through B. We can go C, B, A. That would be 1. We can go across the top and go C, D, A. But then we could also use this middle line. So maybe we go to B, then up to D, then back to A. So that would be C, B, D, A. And then we could do the opposite. C to D, back down to B, and back over to A. So that would be C, D, B, A. And it looks like those are the only ways to do this without going down an edge twice. So our answer would be 4. Now for this part of the question, we're asked how many paths are there from A to F. So the simplest would be A to H to F, that would be 1. Or we could go through G, so A to H to G to F. Now another thing we could do is go to G and do the loop, so that would be A, H, G, G, F. Now what we can't do at any point is we can't go to E, because then we would have to retrace that edge, and we can't use an edge more than once. So I purposely broke this up because the question I really want an answer to is how many edges or paths are there from C to F? Well, we know that there's 4 from C to A, and then if we connect at A, there's 3 from A to F. So to get from C to F, as long as those letters matches those A's, to get the number of paths, we just have to take the 4 ways we can go from C to A times the 3 ways we can go from C to F, and there are 12 paths. So that way we don't have to find them all. Now if you look on the next page, it says example 8 tells you to use the graph above. So they are referring back to this graph. So I'm just going to lay this page here, but I'm going to leave this graph. First thing we're asked is to find circuits of length 1. So if it's length 1, it has to be a loop. So the only loop we see is at G. So we list that G to G. So for a circuit, remember the first and last letters have to be the same. So then we want to find circuits of length 2. That means we can go down 2 edges to get back to where I started. So if I start at F, for example, if I go to G, that's one edge. I only have one more edge to go back to F, and I can't use the one I already used. So it doesn't look like there's any place where I can do a circuit of length 2. What you're really looking for length 2 is something with multiple edges like this. I didn't draw that very well. That would be a circuit of length 2. I would go from X, I'd go up to Y on the top one and back on the bottom one. I don't see anything like that on this graph, so this is going to be none. Now for circuits of length 3, I'm kind of thinking about triangles. I need to go down 3 edges. So notice right here there's a triangle. It doesn't really matter what letter you start with. If I start with F and go F, G, H, back to F, that's considered the same circuit as if I start at H and go H, G, F, H. Since it's the same 3 edges, that's considered all to be the same circuit. So that takes care of that triangle. Now I'm also seeing a triangle over here and a triangle over here. So let's start at C for this one. For this one you could start at C, B, or D. So I'm just going to go ahead and start at C. I'm going to go C, D, B, C. So that would be 1, 2, 3 edges, and I go back to where I start. Then I'm going to do this triangle over here. I'm going to start at A, B, D, A. So if you're comparing your paper with someone else and they write this loop but they start at B instead of C, it's still considered to be the same circuit. Alright, and then finally we're asked to find circuits of length 4. So here I'm kind of looking at quadrilaterals, so I'm seeing a little bit of like a rectangle here. So if I start at D, for example, I could go D, C, B, A, back to D. So that would be 1, 2, 3, 4, 5 letters. That would be length 4. So that would be exactly the same as, say, starting at A and going A, B, C, D, A. Since you're traveling the same 4 edges, it is considered to be the same circuit. All right, now we're going to look at example 9. Here we're asked to list bridges. So for the first example, it's still referring back to this graph. So remember, a bridge is an edge that if I take it out, it breaks the graph into different components. So if I take anything out over here, for example, if I take out CB, my graph is still connected. I can still get from C over to B even if I take that edge out. So nothing over here is a bridge. But A to H would be a problem. If I took that out, that would definitely break my graph into 2 pieces. So A, H is definitely a bridge. Now if I look at the triangle, if I take any of those out, I can still get around to the other part of the triangle by taking the other edges. So the only other one that's a problem is EF, because if I take it out, it's going to isolate E all by itself, and that would disconnect the graph. So EF is also a bridge. Now the last 2 examples, we're not given a picture, so we can go ahead and draw it. We've got a graph with edge list AB, so I know that A and B are connected. I can draw that. A and E are connected, so I'm going to just put E over here. B and C are connected, so I'll put C over here. C and D are connected, so I'll put CD here. And then D and E are connected. Alright, so that's my graph. If I take out any single edge, so if I take this one out, I can still get from D all the way around to C. It'd be a lot longer, but I could still do it. So if I take any of these edges out, the graph is still connected. So this one is going to have no bridges. Okay, now my last one, I'm given a vertex set this time, so let's start with that. Okay, so we have edge AB, edge BC, edge BE, and edge CD. So it looks something like this. If we take out CD, it's going to isolate D. So that one's a bridge. If we take out BC, it's going to cut the bottom part of this graph off from the top, so it's a bridge. If I take out EB, I'm going to isolate E, so it's a bridge. And if I take out AB, I isolate A, so it's a bridge. So in this case, they are all bridges. And you can list the edges if you want. It's AB, BC, BE, and CD.